I'll talk a little bit about the background of the company in this talk. I'll get into what we're building, and then I'll kind of finish it with some use cases that hopefully stimulate a bunch of questions and good debate. And hopefully everybody will enjoy themselves. Before I get started, a few questions to kind of kick this off. So who here had heard of Helium before coming to the meetup? Okay, a few. Who here looked at our website on your phone on the way over? Andrew. All right, there you go. He knows about Helium. So what do people do in terms of background? Who's, say, actively developing an IoT application, be it writing firmware, writing some sort of cloud software for it? A few? Okay. Who's founded some sort of IoT company besides Babak? Cool. All right. Who's brand new to this space? Oh, excellent. You're doing it. Where is he? Good job. Okay. So with that in mind, I want to talk about the world's first decentralized machine network. So Helium was founded in 2013 to solve what we saw, and as I'll get to, what we still see as a huge hole in what it takes to actually build a connected device or application. So we've raised, I think to date, about $35 million from companies like First Mark Capital here in New York City, if anybody knows them, fantastic group. Costa Ventures, Google Ventures, SV Angel, Munich Re, and HSB, which is an insurance company, a whole slew of fantastic investors. And they funded us throughout the years to solve this problem of how do I connect a device to the internet better? How do I just ship a complete application end to end from sensor, I'm going to drop this, from sensor to the cloud and ultimately back to my application. And so we started with a mission, and we're 5 years later, and we still don't think we've done a really good job to solve this. So the Helium platform, as I'll get into, is fundamentally kind of three pieces. It's a module, which does wireless connectivity. It's a gateway, and where that gateway lives is going to be changing very soon, and that broadcasts a wireless protocol, or listens rather, for packets being sent over the air. And then there's a routing infrastructure in the cloud. And so we've built some tooling around this over the years that has seen at this point. I think we've got one of the best views into how the IoT space actually works. And that's what we're getting a visit here from something coming. Okay. Well, this improviser. So, about a year ago, we kind of took a long, hard look at our platform and kind of said to ourselves, why isn't this stuff still easier, right? Gartner's predicting that 50 billion IoT devices are brought online every year for the next 15, 20 years. But more and more we talk to companies doing POCs and no one's really shipping these things faster. The 75% of IoT POCs are failing, if you believe the stats coming out of Cisco. And so we feel that things are still entirely too hard. So the internet succeeded for a lot of reasons, one of which is because people built protocols like BGP, SMTP, DNS, and fundamentally these things were the basis of the internet, and it works well. It's a decentralized system. Oops, there we go. My computer over here can join the Wi-Fi network on whatever Wi-Fi infrastructure exists here and send data to the internet, much like it can at my house just outside of Boston on the Verizon Fios network. It just kind of works. That's kind of succeeded. And so naturally people kind of thought this would work for IoT, but that hasn't happened. So what we have now is a lack of open standards. And so we went back to the drawing board and decided that we needed to really kind of level this playing field, and I'll get into how we did this. But lack of open standards kind of leads you to a state where you're looking at a bunch of different proprietary tech. So you've got, in IoT alone, you've got endless kind of IoT wireless vendors, you've got platform vendors, you've got sensor microcontroller vendors. None of these things are being built in a way that is open and incentivizes people to kind of all build on the same infrastructure. And so when that happens, you end up with fragmented infrastructure, and you don't give people the ability to build on anything very efficiently and easily. So, in the IoT space, you've got cellular providers competing against things like LPWAN providers, and the cellular providers want to just continue to be cellular carriers and carrier data and charge for it. You've got LPWAN providers, the LoRaWAN kind of network operators, and the Sigfoxes of the world, also doing a variant of that very same business model. They're building infrastructure that can't really talk to each other. You've got one LoRa network next to another LoRa network next to an NB-IoT network. As a developer or an enterprise building this, you have to be absolutely petrified. And we've seen this over and over again with enterprises. And so, ultimately, we kept running into companies having a very poor experience trying to build an end-to-end application. And so I'm up here kind of spilling my guts because Helium is very much a part of this problem. That's why we kind of went back to the drawing board. We suffered from the same thing. We tried to lock people into this, closed ecosystem where you had to send data across a proprietary wireless link, and at some point we even had a storage layer. We were asking too much of our users, and it was not easy enough for them to ship things and ultimately trust us. So about a year ago, we went back to the drawing board and said, how do we actually deliver on this vision to build a public wireless network? So if you go back and read the press about Helium in 2013, 2014, we were raising money to build physical wireless infrastructure that competed with cellular carriers inside of cities. And we raised an A round after having built a very nice beta network inside of San Francisco. But the wireless protocol that we were using was just not going to get the job done. So we started thinking, well, show of hands, who pays attention to blockchain, knows enough to be dangerous about it, hates it, who has an opinion on blockchain? Okay. So we kind of jokingly in the office in San Francisco kind of said, oh, okay, what if we used a blockchain to try and figure out how to actually build a proper, decentralized wireless network? And we joked about it for a week, and then we threw it away. And then, a guy named Bones went out and wrote a white paper, and then we looked at it and laughed, and we kind of threw it away. And we did this for a couple months. And then somebody finally said, we might actually be able to use this. So what we ultimately landed on was a system that we are about to roll out in beta, and I'm going to get into all the pieces. Something that we're calling the Decentralized Machine Network, or DMN for short, an acronym you should memorize. And so what is a DMN? So in our mind, it's made up of three pieces. You've got a physical blockchain, and I'm going to get into what all these pieces are. I probably won't get too nitty-gritty on the blockchain stuff during this talk. It tends to kind of go down a rabbit hole, but if people want to talk about it, feel free to ask questions, and if it's going to be too long of a response, I'll just kind of find you after the talk. So we built in our building and are about to release a physical blockchain. It's a brand new blockchain of our own design. It's called the Helium blockchain. And this is a mechanism by which we can, we believe, very efficiently build public infrastructure to make the Helium network a real thing, and I'll get into what that actually is. There's got to be a wireless network, right? We're talking about devices that are needing to send small-ish sort of data, long ranges in a highly secure way. Babak was mentioning devices that are $5 IoT devices. These are things that all run on very small MCUs. There's an RTOS in there. It doesn't really do much. And you're expecting this thing to be deployed and run in the field for 2, 3, 4 years on a coin cell in a lot of cases. And I'll get into some of the use cases and what we're kind of tackling. But there's a lot of wireless protocols out there. We tried to use some available ones, and I'll kind of get into that. But we're bringing a new and royalty-free wireless protocol to the market, which we think is really going to be a game changer. And then open source software. So back to my original kind of assertion that proprietary tech was kind of killing the space. We decided to kind of go all in on this vision. So everything I talk about today is going to be open source and license in a friendly, kind of very permissible way. So all of the firmware, all of the code to build gateways, to build modules, to run routers, to run the blockchain, all this is going to be open source under a nice license. And we're going to encourage people to actually build stuff on this. And so the vision for Helium is that ultimately, if this is successful, once the network is up and running and companies are actually building applications on the Helium decentralized machine network, we could, if we wanted to, just kind of step away and say, oh, look what we did. There's a network. It's running wonderfully. There are millions of devices, billions of devices that are coming online. We've got an ecosystem of people building things on top of this. We could just kind of step away if we wanted to. We won't, but that's the goal. We are not here to lock people into this crazy thing we're building, and by some accounts it is quite crazy. But we are kind of all in. So the crux of the Helium network, and really where the last mile is created, is in a piece of hardware called the gateway. So the gateway, and that's bigger than what the actual gateway is. Anybody have a Roku? You know what a Roku is? Yeah. So imagine like a Roku in terms of size. So the Helium Gateway is a piece of hardware that does two things. It runs the Helium blockchain, and I'll get into the mechanisms of the blockchain and why it's important to the success of the network. Excuse me. And it also forms the backbone of the wireless network. So the Helium wireless protocol that we've built, which is called WIP, which I'll kind of touch on here at a high level, but not really dive too deep into. The gateway itself is made to ingest data from devices running the Helium wireless protocol, WIP. I'll talk about this at the end, but if you go to whitepaper.helium.com, we talk about all pieces of this infrastructure, and we go into much more detail on all this stuff. So the gateway, which is being deployed in limited beta in the next few weeks across about 50 US cities, Chicago, Boston, New York, some more obvious ones, and then a bunch of Bay Area cities, is made to be deployed in homes, in businesses, in factories, on roofs, pretty much anywhere where you have access to power and then some sort of backhaul, because sensors, be it your water cooler, your temperature probe, your connected vending machine over here, which is on the network, are sending data. There's a gateway within range that collects this data for you and then passes it on to some cloud-hosted endpoint that you, the device owner, owns. But the idea here is that people will deploy these gateways, and Helium will provide a mechanism for compensating gateway operators, and I'll talk about that. The gateway itself is extremely low power, so for people who follow the blockchain space, it uses about 13 watts of power at peak, which I think is maybe 6 cents a day, based on San Francisco's PG&E kilowatt hour pricing. So that's going to be much higher than anywhere else. So extremely low power, efficient to run, and you as a gateway operators, and I hope everybody in this room will consider being a gateway operator, are compensated for being part of the network. This is quite literally a network that is built by you. And so this drives right to the core of our kind of decentralized mission. Okay, so we've got this network, or we will soon have this network, and I can talk more about our roadmap. And once that network is deployed, it's useless without people who actually want to use it. So the Helium module is a fully built, anybody do wireless or RF in the room? A couple, cool. So it's a fully built wireless module that is compatible with the Helium wireless protocol. So again, it's called WIP. We're going to be releasing a specification very soon. And it's built on a tidy little radio from TI called the CC1310. Anybody ever use the CC1310? It's a great little radio. Nobody uses it, I think, because TI's tooling is so poor. But it's fantastic sub-gigahertz radio. So the Helium wireless protocol is based on sub-gigahertz in the ISM band, so 902 to 928 megahertz in the US and a few different frequencies abroad. And so in this module, you've got a complete package to literally build an entire sensor to be deployed onto the network. So in addition to just the radio protocol, which is again embodied in this module, you've got a crypto stack which handles your private key your private key storage and your SSK storage and generation, and you've got a processor. So there's two processors on this thing, and you've got I think it's an M4 bundled in with this module to drive your sensor applications. And so if you can fit an application, I think inside of 32K, you can just use this off the shelf. And so we're targeting $4, $5, $6 US at scale for this, and probably much lower as we start to roll out big manufacturing runs with us and our partners. And you literally have to do nothing else besides build your actual sensor, right? So if you've got a temperature sensor that sends data over SPI, you can just wire this directly to the Helium module, and for $5, you've got the whole network package built in. And so as a developer, you program this with a development kit that'll, it's running on a great open source project called Talk, which I can point people to, but it's a Rust-based RTOS that runs on devices that we've customized for this, and essentially lets you as a developer write sensor programs in a bunch of different languages that compile down to something super efficient and run directly on the microcontroller. It's pretty damn badass. So the module itself is going to give you fantastic range. We're talking, so that gateway that I just showed right here. So who's been to San Francisco? A few people, I imagine. So we're doing testing right now on this gateway. We can get about well over 12 miles line of sight range, or not even line of sight, through buildings, across foggy things, into Marin, which is just north of San Francisco, with this. So for a city like San Francisco, for example, where a gateway provides hundreds of miles of coverage, we can cover that city with probably 20 to 30 gateways. Now, it doesn't mean it's completely covered, because we're in the business of trying to have people feel very confident that their packets are going to get from the edge back to the cloud. So I'd like to see more than 30, maybe 100 gateways to totally saturate San Francisco. So New York is going to require more than 30 gateways, but you kind of get the idea. And so we can build coverage, and people who are deploying gateways, Helium gateway operators, can build coverage very efficiently and very cheaply on our behalf. And so the first version of this gateway, over here again, will be available for order in probably 6 to 12 weeks. A big range there, but 6 to 12 weeks. And this one's going to cost $299 US. So very cheap. And that'll connect to Wi-Fi or Ethernet wherever you deploy it. We'll have ruggedized versions that connect to cellular networks if you want to, that you can deploy on top of, say, grain elevators, because we have people doing that. And so this is the kind of the top high-level, say, 30,000-foot view of the decentralized machine network. You've got your devices, and I'm going to talk about some use cases, but these are the machines running a Helium module or a Helium-compatible module. So because it's all open standards and open source, you can actually build your own version of the module, and we're doing some of the groundwork now to get some large manufacturing partners interested in building their own version of a Helium module that might have, say, one less LNA on there, because you don't actually need that for the use cases that you're targeting. So a device is out there transmitting data. It can be sent to any gateway that's within range, and as I just said, these things are getting hundreds of square miles of range. And then from there, the data is pushed to a cloud-based endpoint through the Helium routing infrastructure. So common clouds that we see in our current production applications are Google Cloud IoT, Azure IoT, AWS IoT, and then people are using services that listen on things like MQTT, HTTP. And so part of the beauty of what we've built is that from a security perspective, the module itself, when you deploy something on the Helium network, it is a hardware authenticated root of trust from the device all the way back to your cloud operating environment. So we've got a mechanism called a channel on the cloud side that just connects to your cloud infrastructure, and you then have a hardware authenticated device talking from the edge back to your cloud without doing any real heavy lifting. It's quite great. So to talk a little bit more about the network itself, I'm going to talk about some use cases in a second to kind of drive home where we think this is going to go. So in the decentralized machine network, we succeed when people deploy Helium coverage. And so I talked a bit ago about how we went back to the drawing board and said, hey, could we use this crazy blockchain thing to figure out if people actually want to build a network and help large enterprises and small developers and everybody in between deploy connected devices. And so and the network is incentivizing people to deploy coverage using something called a Helium token. So for people who pay attention to cryptocurrency, the blockchain is brand new. It's of our own design, and it's built for physical world devices. And I'll talk about one feature of the blockchain in a second that the network kind of gives to people. And with that new blockchain is a token that's native to the Helium blockchain, just called Helium, HLM. And so users, or gateway operators rather, are compensated in two ways for kind of deploying coverage. So when Andrew, where'd Andrew go? So when Andrew buys a gateway in a couple weeks and puts it right here in this window, he's going to be creating just remarkable coverage for, I don't even know what part of Manhattan this is, but whatever part of Manhattan we're in is going to have fantastic Helium coverage. And so because he's doing that, he's getting compensated in two ways. His gateway is part of the Helium blockchain and is part of the mining operation. And there's a very kind of predictable way that gateways are capturing Helium tokens for mining. But as time goes on, when people start to deploy devices, so Andrew's got a gateway here, he's got a gateway at his apartment. I'm going to talk about a Nestle use case in a second. As Nestle starts to roll out connected water coolers inside of New York City, they're sending data across the Helium network, and Andrew is capturing Helium token for actually routing their data. And there's a bunch of mechanisms by which that happens. But we think that this is the way that we build a network that is sustainable and very open and very decentralized without the need for spending billions of dollars of CapEx trying to cover the United States. So this is kind of the lead into some of the use case things. But the gateway that we've built is capable of handling hundreds of thousands of devices, sending data. And for anybody who cares about kind of hardware engineering and wireless and RF, the gateway itself, we've got a few good blog posts on this, is built on something called a software-defined radio. Anybody ever work with an SDR? Kind of a magical, crazy thing. So it's built on an SDR, which means it's capable of, or the way that we've built it anyway, means it's capable of ingesting just massive amounts of wireless data across a huge chunk of the spectrum. So because of that, we can connect hundreds of thousands of machines in parallel, especially in cities that have tens or hundreds of gateways. So it's a very scalable way to build out device connectivity. Okay, last kind of feature I want to talk about, because I really think this kind of drives home the differentiator between what the Helium network provides and kind of everybody else in this space. I can go on and on about the blockchain pieces and how interesting and cool that is, but really what it boils down to is giving a company like, I don't know, UPS the ability to ship something that you can track down to the foot level. So because we have, briefly, the Helium blockchain has something called proof of coverage. So proof of coverage basically means that Andrew's gateway deployed here is being constantly verified by other gateways that are peers geographically. And so we use known constants like the amount of distance at or the amount of energy output by RF and the speed of light, things like that, to basically construct a proof around how efficiently Andrew's gateway and peers to Andrew's gateway are building the network. And through that proof, and another proof called proof of serialization, we can pin down and feel very comfortable about the location of Andrew's gateway cryptographically. So I can actually have a cryptographic anchor that says Andrew's gateway is located exactly right here. So if I've got 10 of those in New York, and I've got a device sending packets across the network in New York, if I capture multiple copies of that packet, which is a thing that we can do, I can then look at the timestamps on those packets and do some solving using something called time difference over the air, TDOA, and tell you at a very fine-grained level just where exactly that device is. And that's just with that module that I showed back there, that $5 US module with no additional special hardware on top of it, no GPS, nothing like that. And so because of the way that we've built the gateway, using the software-defined radio and a few other kind of mechanisms, we'd actually get nanosecond level timestamps down on the sensor. So devices are sending data across the network with nanosecond level timestamps. This essentially gives us the ability to, as the coverage density improves, tell you exactly where something is, which is remarkably powerful. So the network just gives you built-in location. So if you're building a sensor and you didn't even want to have a location tracking feature in it, you just get it for free. Now there's some mechanisms in the network that require you to pay slightly more for that piece of traffic, for example. So if you're just sending a temperature sensor packet across the network, it might cost you 1/100th of a Helium token. If you've got to send 10 packets to geolocate yourself, it'll cost you 1/10th of a Helium token. But I would argue that that's going to be very much worth it. So this is the biggest feature, I think, in my mind from an end user perspective, where the Helium decentralized machine network really will set itself apart when it comes to companies wanting to build stuff on top of the network. Okay, so I'm going to bring it home here with a few use cases, and then sounds like I'll stop for questions. Yes?
You just mentioned pricing.
Oh, we got to get a mic here for you.
You had just mentioned pricing. So how do you determine, a 100th of a Helium token for what amount of data that gets transmitted?
Yeah, so I'm not to repeat the questions, right, Jolie? No repeating questions. So, so pricing for traffic on the network essentially gets determined dynamically as the coverage gets built out. And we think that as more people deploy gateways and start providing coverage, the price of data traffic will end up dropping as people deploy coverage. One second. And so we don't set the prices. We can't actually say what the prices are going to be. But as the network gets built out and there's more density and there's more people competing essentially for the transaction fees on top of those packets, the price will come down. And so cost of traffic will be dictated by that. Second question.
You talked about building out networks in large cities. What about rural areas and how are you going to expand?
Yeah, so we have intentions of covering everywhere. We're kind of in this perpetual, not perpetual, but at the moment, this very significant chicken and egg situation where we have to build a network and then have people build applications there. So our strategy is to, I mentioned, do this beta network of about 200 gateways across 50 cities in about 6 weeks. And then from there, we're going to be going kind of city by city and finding partners in these cities to build applications as we do that. Rural areas, we suspect, will be covered relatively quickly. The one hitch with the rural area is that due to the nature of how the gateways verify each other, they have to be within radio frequency range of another gateway. So a single gateway in the middle of Topeka, Kansas, for example, is going to have trouble kind of participating in the network because it does not have any geographic peers to verify it. Sure, yeah. So what I would recommend is that if you want to deploy something in Maine, find 3 friends, have them get a gateway, and then from there you can build the start of a coverage network. It's a great thing. 6 weeks. Right. Yeah. There's. Yeah. Let's do one more question here, and then I'll move through the use case slides here. Oh, that's actually this guy.
How many devices can a gateway handle?
Yeah. So that is a highly dependent question based on how many devices are transmitting, how much data is being transmitted, what's in the middle. But the gateway is built to use very narrow band channels and to do frequency hopping very quickly. So we can support hundreds of thousands of devices with one gateway. I wouldn't recommend that you do that. In fact, what I would hope would happen is if there was an area where there were hundreds of thousands of devices sending traffic, somebody would say, hey, I'm going to go capture some of that helium token revenue and deploy a gateway to help kind of defray, he's taking all of this token, I'm going to come in and take some of it. Yeah, but on the order of hundreds of thousands. Oh, question up front here, Andrew. Yep, here we are.
The token economics, can you just briefly explain how the mining is done and why would anybody need to hold? I mean, I assume it's a utility token.
Yeah, can we talk about that after?
Okay, sure.
Okay, I'll talk about the token economics after just to make sure we don't get too far down the rabbit hole. Hold that for 1 second, Chris, is your name. I'm going to just move through some of these use case slides and then I'll take questions. So I mentioned before that one of the biggest distinguishing features I see for us is this thing called built-in geolocation, which flows from the blockchain and the proof of coverage that we've built. So one of the use cases that this enables is the ability to put location on pretty much anything, especially if the cost kind of justifies it. So here we have a mock-up of essentially a smart cap. So anybody work in the pharmaceutical industry? No? Huge problem for top 20 drug manufacturers in the world is having visibility into the supply chain when it comes to things like cancer drugs. So a vial that is, about the size of a roll of quarters holds $3,000 to $5,000 worth of a very valuable and super important cancer drug. Huge problem with this is counterfeiting and theft. These things go missing all the time off backs of trucks, and people are building or making fake versions of these and trying to sell them. It's despicable, but it happens. So we're working with a partner that does sensor engineering and a very large pharmaceutical company that really wants to solve this problem to essentially build a smart cap. So imagine that module that I showed you a few slides back built into the top of this cap. And that provides location, provides temperature, and it provides shock. So it has this thing tilted left or right. And so whereas this would be exorbitantly expensive with a GPS module on each one of these caps, the battery would die in a number of months, if not weeks. Built on top of the Helium network, this is a feasible use case. And this is one that we're very excited about. A partner of ours is Nestle. So Nestle has a business unit called Ready Refresh, which has been working with us and another one of our partners to build what is a sensor that essentially, I'm looking around the room to see if there's any. Yeah, so you guys have seen these things. They're the 5-gallon kind of big plastic things that you lug over your shoulder and put on top of a dispenser and drop half the time. So they have millions of these things in the US. They're not all running helium. Hopefully at some point they will be. And they don't know what's in them. They've got a delivery truck that shows up every couple of weeks, drops off 10 bottles of water. Sometimes they don't need the water. Sometimes they've run out 2 weeks before, and there was a phone call, which resulted in a truck being rolled and added cost because they ran out of product. So they came to us and said, hey, how would we go about getting simple data out of one of these water coolers? So we work with them and a partner of ours to build a sensor that retrofits to a few different SKUs, essentially, of this water cooler that can be deployed very quickly. And it will tell you in real time exactly how much water is being drawn from the bottle itself. So this is a huge leap for them because it gives them not only real-time insight into how much water is being consumed, and they can kind of automate the kind of order flow and better customer service, but they now get insight into how people are acting inside their homes and businesses, how much water is being consumed. And they've got kind of big ideas on building a bunch of different connected products, but this is the first one. Okay, who here has a dog or a cat or a pet that they love? Yeah. So tracking, I mentioned tracking of valuable drugs and vials. I mean, tracking of valuable living things is very much a great use case for helium, for a lot of the same reasons that the drug tracking use case was. We've got a partner called Envisaleash who's in the process of building this application on top of helium, where they're looking for a way to give consumers the ability to track a pet anywhere. It doesn't have to be within range of Bluetooth. It doesn't have to be on your Wi-Fi network. Be able to accurately geolocate that dog or cat or bunny or hamster whenever, a set pointer in the day or whenever you kind of want to know where it is. So again, this is another use case that we enable due to the fact that the module to go on the collar is so cheap, and the ease of acquiring location data from a sensor once deployed is just built right into the network. And the last company I'll mention is Wallow. So Wallow is a cool kind of fast-growing startup out of Southern California, and so they're building a whole suite of products that are targeting kind of residential communities. So the first thing that they've built is a kind of a swing app control mechanism, or swing gate control mechanism for gated communities. So imagine you're approaching a community where you live, you have to get in. Apparently, most of these things still have kind of punch dial sort of things from like 20, 30 years ago. And the code is a thing that's kind of just well known everywhere. So it's a first world problem, but it's a problem in communities like Southern California where people want to just go park and be next to the beach. So there's 20 people who live there, but 1,000 people show up and go park there and head off to the beach. So the first thing that they're building is a way to do essentially access control for gates. So with the Helium network, they deploy coverage where needed. So they stand up a gateway, deploy coverage to cover that for their gates on top of community, and then from there they do data capture and control. So I didn't talk about this too much, but the wireless link is fully bidirectional. So if you need to send a command to pull a pin on top of a sensor, for example, you can do that over the Helium network. And so very excited about the guys at Wallow, Sunil and his team. They're doing really cool stuff. So with that, I will take questions, and I'll start with Babak in the back.
Yeah, great talk, Mark. You had earlier mentioned proof of. Mm-hmm. Where is the proof of, I don't want to use the term proof of work, you use proof of...
Coverage.
Proof of coverage, and there was also proof of...
serialization.
Serialization.
Yep.
Are they the same thing?
No.
Okay.
So it's killing me that I can't repeat the question. It's just a force of habit. So whitepaper.helium.com. We've got a very nice, fairly technical white paper for anybody who's a fan of math. And so we use a new proof called proof of coverage to, what exactly was your question? How does it work?
No, my question was if there were two distinct different things, and where exactly did the proof occur, the work associated with the proof occur, and what's the impact on the hardware?
I see. Good question. So the majority of the computation related to the blockchain happens on the gateway themselves. So the gateway that I just showed you, deployed in your home here on this window, is a fully functioning member of the Helium blockchain. It's a physical instantiation of the blockchain living on the edge of the network. So using the onboard resources, so I think it's got an A15 processor and not a huge amount of storage, it's got a few PRUs and it has that SDR. We do the majority of the computation for the blockchain on top of that gateway itself. And so a short way of kind of explaining how it works, we needed a system where we could use the gateways to provide a useful proof to the network. So Bitcoin, for example, uses just a SHA-256 endlessly and just expends a bunch of energy, and they produce a hash that solves a problem, but nothing useful comes out of that. With Helium, we have gateways constantly proving that other gateways are doing their job, and from that, we can actually produce a point-in-time representation of how useful the network was. And I can make a guarantee to my customers that says, hey, there's 100 gateways in New York. 95 of them are doing an excellent job, such that there's a score associated with each gateway. Their mining score is off the charts. If you go send a packet out of Bryant Park, there's a 99.9% chance that that's going to fly through and end up at your infrastructure. So the gateway itself and the gateways are doing the proof of coverage computations on the gateway. And then we use proof of serialization just kind of as an added. Proof of serialization deals more with time and guaranteeing time between, in our case, physical gateways, whereas proof of coverage is more about RF and how the wireless is working. We can talk more about that. You had a question about blockchain.
Yeah, before about.
Oh, hold on.
The question was about economics.
Yeah.
Like in general, how's the mining work? I mean, I understand that if you have a gateway, you get rewarded for this, but you create your own. How do you distribute the tokens? Do you create them off the bat? Are they ERC20? Are they you have your own?
Okay.
So what's kind of high level logic for the
so the high level on the token, so it's called the Helium token. It's a token that's native to the Helium blockchain. We will have sometime in the near future just generally some sort of token generation event where some portion of the eventual total pool of tokens is created and released into the wild. We're not really ready to talk about what that is just yet, but it'll be a thing where tokens are distributed, and then we'll start kind of moving those out to the world. So that'll be a small portion of the entire set of tokens, somewhere in the 0 to say 10% range. And then there, year on year, the mining will produce some kind of diminishing rate of inflation that adds to the entire pool, such that over 20, 25 years, all the tokens have been produced. The gateways capture tokens in two ways, as I mentioned. One is through transactions, so people paying per packet, and then the other is through mining rewards. So
the same token or
same exact token. It's not an ERC20 or some other variant of the ERC spec. It is a Helium token native to the Helium platform.
And all the settlement and services paid in tokens as well, right?
Correct. I'll repeat it. So pretty much all the transactions on the network, and we hope at some point transactions that are not directly related to the Helium network, are paid for with Helium tokens. So every device sending data across the network is paying that. The device itself is not doing the paying. There's something called a router, which is the cloud-hosted piece of an organization that controls the tokens and kind of controls who gets access to all the data. So that router actually pays the gateway operator in real time for that traffic, but essentially that's how it works. Over here we have a question here, and then one over there.
Okay. Do each of the gateways require a backhaul connection, or can you mesh them together to share a backhaul connection?
So the gateways currently all require a backhaul connection. So they do mesh, but not for purposes of sending device data. They actually communicate over wireless for the proof, but that's it.
Okay. So the problem that I see is that to be profitable, your ability to mine tokens has to exceed the cost of your backhaul costs. And your backhaul costs could be very expensive in some areas, let's say New York City, versus perhaps in the Midwest where the costs might be lower, but your token value remains constant regardless of your geography.
Sure. Yeah. So I would disagree that the backhaul costs will get exorbitant. So we've got Wi-Fi, Ethernet, and cellular backhaul. Cellular backhaul is a feature that you'd pay up for, right? So we have an agreement with an MVNO. That's a great company that does all the data backhaul for us, and they're actually ready to take payment for their services in Helium token, which is a big win for us. And so there might be a situation, for example, where say there was a company that wanted to deploy an application out by an airport, and the only backhaul that you had was cellular. And because you were out there providing coverage, you could charge a premium for that. You could justify the cost of the cellular backhaul. As far as Ethernet or Wi-Fi, that infrastructure already exists. So that gateway is going to connect to your home network, to the timescale network here in this building, and then from there, the data is going to be very small, like negligible. You won't even notice it. If it gets to the point where it is noticeable, we've done a really good job, and then we'll deploy more gateways. So I would disagree that the cost of the backhaul is really going to be prohibitive. I don't think it's going to be a problem. Good question. Oop, 2 over here.
What sort of data rates do you anticipate being going from a device to the gateway?
Yeah, good question. So this all depends on how many gateways and how many devices are deployed and all those things. But the sort of applications that we're targeting, assuming a relatively good density of gateways, is 20 kbits a second and below in terms of data rates effective from the device to a gateway, or from a device to the cloud.
So you mentioned that you rolled your own blockchain. Why did you choose that over like Ethereum?
Yeah, so the biggest thing for us was that we developed something that was actually useful, meaning we wanted whatever proof that had to be done to kind of contribute to the longevity and the value of the network itself. So that was kind of the big driving factor. As far as the use cases go, Ethereum and using the Ethereum platform and something like an ERC20 token, for example, would essentially require us to kind of pre-mine all of these things, which didn't really fit with our use case. I hate to throw out Ethereum isn't scalable, but with the instantiation of the Helium blockchain using a consensus protocol called the Honey Badger protocol, which is quite an amazing name, we're able to push kind of thousands of transactions a second through. And I also had to be able to make guarantees to my customers. One of the first questions I got was, I've read about blockchains, Bitcoin and Ethereum are quite interesting, but they're quite slow, 5, 10, 15 transactions a second. How do you guys reconcile, the fact that a blockchain is slow with the idea that my data from the edge has to get back to my cloud in 300 milliseconds? That's not going to work. And so the system that we've built actually allows data from applications to be pushed to the cloud in parallel as the blocks are being mined. So those are kind of the primary reasons. We kind of go into more detail in the white paper if you want to see more. Right behind you, actually, and then.
I have 3 questions. Is blockchain validation on the gateway done automatically, like with smart contracts or something?
Not really. So the way that it works is a group of nodes is elected based on a bunch of different criteria, and then those nodes are responsible for mining the block.
Or do they talk to each other to?
They do, yeah.
And what are the telcos doing while this is going on? I mean, you're taking their business away.
Right, so we're not taking their business away yet, but we hope to very soon.
How fast can you do it?
Yeah, we hope quite quickly. So I actually thought he was going to ask about the kind of telco eventuality. There's a few different ways that it could go, but I suspect what will happen is that we'll end up working with 1, maybe 2 telcos based on this. That's not happening. I'm not saying that it is. But if we do our jobs right, they'll start to notice how much traffic is being pushed to the network, and then from there they'll hopefully want to come work with us. We have good relationships with a few of them, but it remains to be seen how quickly we can.
This is classic disruptive technology.
We hope. We certainly hope. Yeah. Anything else?
I'm speechless.
Gateways in Maine. You're going to buy some, right?
Yeah.
Good. How much more time do we have? I guess we'll do, 3 more questions and I'll stick around. Up here.
So I had a question about, we're using LP-WAN currently, so familiar with the architecture they're using here. So yeah, it's fantastic technology. So what is the maximum packet size? And also like Sigfox and LP-WAN, they restrict the time on the network, right? That you can communicate?
Yep.
Do you have any restrictions like that?
So the only restriction that we have is whatever is imposed by the FCC when we get our module kind of certified. I can tell you that the Sigfox specifics, and if they've not changed, there's still something like, 12 packets a day, 100 bytes the whole day. Quite ridiculous. We're not beholden to that. The first question was
Packet size.
packet
max
size.
and pass.
Oh, okay. I'm blanking on what the specific packet size. It's in the hundreds of bytes, but we have a way to chunk packets over the air. So in the event that you want to send something that's slightly larger, which I wouldn't, you can do it if you want to. I would recommend that we figure out exactly why you're sending those larger packets before you do it. We can break that up at the operating system level, at the Helium level on top of the module, and then send that back over the air.
Sure. Great. Thanks.
One more, and then we'll go all the way out there.
Okay. Just a quick question. Now, what's your POC locus for New York City? Are you just considering New York City or the metro area, or what's your range?
So we're targeting the major kind of metropolitan areas first, and then our hope is that we'll build out via people like our friend here. What was your name? Eleanor. So like Eleanor wanting to disrupt telcos in Maine, we hope that people will kind of push out outside of the cities. Or what's going to happen is our customers who are very eager to use this will actually deploy gateways themselves. So for example, we've got a customer called Agulus out of South Carolina that builds irrigation systems for non-row cropping farms. His name is Matt, is very excited to deploy a bunch of helium coverage because one of the benefits we didn't really talk about here is if you deploy gateways to kind of route data for your own devices, you're mining helium tokens and capturing tokens. So you're paying for your own traffic, which is quite fantastic. So we have companies that are very excited to deploy gateways in addition to actually building applications on top of the network. And then I think just one. Oh, okay, we'll do two more, and then we'll call it.
Hello. So I got here a little late. Sorry if this is a little repeating, but a few years ago there was an organization based in Amsterdam called the Things Network.
Yep.
And I was just wondering if I know they used LoRa and they have their own gateway. Could you like build with them and cohabitate, or
Yeah.
frenemies, or because you're both open source?
Sure. Yeah. So we actually like the Things Network quite a bit. We like what they do. We kind of applaud their efforts to build grassroots coverage. Ultimately, we think that they're going to fall short because they're not kind of giving people deploying the incentive mechanisms to deploy. Our biggest problem with LoRa is the fact that the spec is tightly controlled by Semtech. So we tried very hard to use LoRa. We did as much testing as we could. We talked to every member of the LoRa Alliance and kind of technical leaders of that organization. Without getting into too many details, we couldn't make the protocol and the business model work on top of how the protocol functioned. So we tried. Writing a wireless protocol is not a thing that I would recommend anybody do for profit. So as far as the Things Network goes, interoperability with those guys and generally the LoRa ecosystem, probably not anytime in the near future. If their modulation scheme was discernible, I could figure out whether or not we could ingest that stuff. On some timeline, we might be able to do it. And, longer down the line, Helium has ideas around non-sub-gigahertz or non-helium wireless protocols. But yeah, for the moment, it's not the sort of kind of collaboration we could do. But again, they've done great work, but it's not something we could work with right now. Thanks. All right, one last question, and then we'll call it, and we'll take other ones right here. Oh, he's got the mic. Okay, two more, and then that's it.
Okay. Is QoS, quality of service, built in? I foresee a problem where if I have a gateway that I'm trying to use mostly for my purposes, and then my neighbor wants to either hog up the services or for that matter a denial of service attack, how can I allocate the bandwidth that's available just to certain users?
It's interesting. We usually get the quality of service question from the other side, as in how do you guarantee that my device data will make it across a network that's powered by people? But we don't have any mechanisms built in right now to specifically say, I own a gateway. I want to make sure that 80% of the RF bandwidth is dedicated to devices 1 through N. It's just not something that we do. I would recommend that if you have a gateway that your neighbor is abusing, you just start charging him more money for traffic. And then he'll either find another gateway, or you can deploy another gateway and capture more of that. As far as a device to the network sort of QoS, that's kind of something that we'll have to develop over time. So much like Amazon and Google Cloud IoT offer 3 nines and 5 nines, and if they don't hit those SLAs, you're entitled to some sort of reduction in price or rebate. We'll build mechanisms around that, and then start guaranteeing some level of SLAs based on the network saturation in certain areas. it's a hard problem. Last question.
And the question about IoT vendors, how do they get the tokens, and do they get charged? And how does economic work on their end?
Yeah, so the people deploying devices?
Yeah.
Yeah.
Deploying devices.
So there's two mechanisms by which people can get tokens. One is that they can actually come to Helium directly. So I didn't really talk much about the business model. We don't see the token being a thing that we hold and pray to appreciate, because that kind of ruins it for the people that are trying to spend tokens to send traffic. But much like Twilio, for example, will just continue to give you credits to send SMS messages across their platform. You can envision that sort of feature as part of an enterprise package offering that Helium has on top of the network. So you can get Helium tokens from us, and then once tokens are released, it is our hope that they will end up on an exchange or two, where people can go proactively buy tokens. But for the majority of the larger enterprises, I guess on a general topic, a lot of the blockchain kind of adoption sits with the product companies trying to abstract away a lot of these new things. So, for example, the people at Nestle are quite excited about the network, but paying for data traffic and tokens is something very foreign to them. So, questions are things like, this is fantastic that I can pay per packet and that the cost looks like it'll be low, given that the pricing dynamics are coming, they'll be pushed down, but I have to model this for 3, 5, 7 years, right? How do you guarantee that the traffic costs are going to be X and Y? So, these are sorts of things that we have to... Exactly, yeah. So we have to kind of build in these protection mechanisms on top of kind of the enterprise services and support layer that we build. But yeah, that's kind of a developing situation. Okay, let's cut it there. Cool. All right, thank you so much. My email is up here. I'll be here. Thanks.
I think that was like 47 questions. It's crazy. That's a record. Let's give another round of applause for Mark. That was awesome.